Dear friends, we have already discussed in the last lecture about various types of operating systems, their advantages and disadvantages. There are many angles to view an operating system. One is by examining the services it provides. Second, by looking at the interface it makes available to users and programmers. And third is by disassembling the system into its components and their interconnections. In this lecture, we will discuss some of these aspects of operating system. First, we will start with factors in operating system design. In order to design a successful operating system, the designers have to have a clear idea of what they want. Lack of a goal makes it very hard to make subsequent decisions. While designing any operating system, there are many factors which are to be considered. Major factors to be considered are discussed. First is performance or efficiency. This is one of the most important factors while designing any operating system. Each operating system should perform maximum jobs in minimum time using limited number of resources. High throughput with high degree of multi-programming is always required to enhance the performance of the system. Second is CPU and resource utilization. Every computer system should ensure the maximum utilization of CPU and peripheral devices. This will also enhance the performance of system. Third is correctness or reliability. Along with performance enhancement and efficient utilization of resources, operating system must ensure to provide correct results and should be reliable. The execution of processes should be error free, having no software crashes. If some part of the system goes down, most commonly a user process, it should not be able to take the rest of the system down with it. The system design should make sure that the various parts are well isolated from one another. Ideally, parts of the operating system should also be isolated from one another to allow independent failures. Fourth one is maintainability. The operating system has to manage the hardware. In particular, it has to take care of all the low level chips such as interrupt controllers and bus controllers. It also has to provide a framework for allowing device drivers to manage the large input output devices such as disks, printers and the display. Fifth one is abstraction. The most important but probably hardest task of an operating system is to define the right abstractions. Some of them such as processes, address spaces and files have been around so long that they may seem obvious. Other ones such as threads are newer and are less mature. For example, if a multi-threaded process that has one thread blocked waiting for keyboard input forks, is there a thread in the new process that also waiting for keyboard input? Other abstractions relate to synchronization, signals, the memory model, modeling of input output and many other areas. Sixth one is protection and security. Since multiple users can be logged into a computer at the same time, the operating system needs to provide mechanisms to keep them separated. One user may not interfere with another. The process concept is widely used to group resources together for protection purposes. Files and other data structures generally are protected as well. Making sure each user can perform only authorized operations on authorized data is a key goal of system design. However, users also want to share data and resources, so the isolation has to be selective and under user control. This makes it much harder. Even when there is only a single user, different processes need to be isolated. Seventh one is provide primitive operations. Each of the abstractions can be instantiated in the form of concrete data structures. Users can create processes, files, semaphores, etc. The primitive operations manipulate these data structures. For example, users can read and write files. The primitive operations are implemented in the form of system calls. From the user point of view, the heart of the operating system is formed by the abstraction and operations on them available via the system calls. Other than these primitive factors, there are many factors to be considered while designing an operating system. It includes non-engineering factors, commercial factors, standards and open systems, size, complexity, capability to deal with concurrency, hiding data of one user from other user, sharing of data, long life of operating system, providing generality of operating system, portability and compatibility with previous operating systems. Next, we are going to discuss basic operating system functions. The operating system provides mechanism for supporting an abstraction for computation for the process and the managing resources used by the community of processes. Operating system functions can be classified into 6 main categories. First, process management. A process is program under execution. A process needs many resources for its completion. Operating system is responsible for providing various resources to the process and reclaiming these when process terminates. Operating system is responsible for creating and deleting processes, suspension and resumption of processes, process synchronization, process communication and handling deadlocks. Second is device management. Processes require interaction with various input output devices connected to the computer. Operating system manages input output devices by efficiently transferring data from input output streams linked with input output devices to memory buffers for manipulation. Device driver software is installed to assist operating system to run input output devices. A user can use a computer system only via these input output device drivers. Thus, by making user not directly interact with the input output devices, operating system protects the computer from any unintentional activity by unauthorized user and makes the computer system efficient. Third is memory management. Memory contains accessible data shared by the CPU and input output devices. Both CPU and input output devices read and write data in main memory to execute processes. Several processes are kept in memory to efficiently use CPU and input output devices. To accommodate multiple processes in memory, main memory is logically divided into partitions. Operating system is responsible to look after that one process does not interfere the memory area allocated to other processes. Operating system also takes care of that which parts of memory are currently in use by whom and which parts are free. It also decides which processes are to be loaded into memory when memory space becomes available. It also allocates and deallocates memory space as needed. Fourth is file management. Permanent information is stored in computers on several different types of secondary storage devices like magnetic tape, magnetic disk, optical disk, etc. Each of these storage media has its own characteristics like capacity, access speed, data transfer rate and access method. To use the computer system more conveniently, the operating system provides a uniform logical view of information storage. The operating system abstracts from the physical properties of its storage devices to define a logical storage unit called a file. A file consists of related information that is stored as a sequence of bytes and records as defined by its creator. Commonly, files represent programs and data. Files are further organized into directories. In connection with files, operating system is responsible for creation and deletion of files, creation and deletion of directories, mapping of files on secondary storage devices, taking backup of files, accessing of files and directories, etc. Fifth one is security and protection. Operating system provides security to the data and programs of a user and protects any interference from unauthorized users. Also, operating system provides mechanisms to ensure that the file, memory segments, CPU and other resources can be operated by only those processes that have gained proper authorization from the operating system. Sixth one is network management. Network of computers is often seen in organizations. The computers share their resources and connected via a communication network. Access to shared resources results in computational speed up, increased data availability and enhance reliability. Operating system is responsible to manage the network and its resources. It generalizes the network access as a form of file access and hides the complex details of networking and various protocols used in networks from users. Next, we are going to discuss implementation considerations. CPU modes are operating modes for the central processing unit of some computer architectures that place restrictions on the type and scope of operations that can be performed by certain processes being run by the CPU. Most processors can run in one of the two modes, supervisor mode and user mode. First, we will discuss supervisor mode. There are specific instructions that can only be run in supervisor mode, also known as kernel mode. These are called supervisor instructions, also called privileged or protected instructions. For example, input-output instructions are supervisor instructions. The supervisor mode is used by the operating system's kernel for low-level tasks that need unrestricted access to hardware, such as controlling how memory is written and erased, and communication with devices like graphics cards. Only trusted operating system procedures are meant to execute in supervisor mode. The execution of any procedure running in supervisor mode is called a system call. In supervisor mode, all machine instructions and all memory addresses are available. Next, we have user mode. In contrast, user mode is used for almost everything else. Applications operate within user mode and can only use hardware by communicating with the kernel, which controls everything in supervisor mode. When a computer first starts up, it is automatically running in supervisor mode. The first few programs to run on the computer have unlimited access to hardware. When operating system passes control to another program, it can place the CPU into user mode. In user mode, a subset of the instructions are available. Typically, input-output instructions that change the mode bit are not available. Using those instructions causes the process to halt and stop. In user mode, a subset of the memory addresses are available. In user mode, programs may have access to a more limited set of CPU's instructions. A user program may leave user mode only by triggering an interrupt, causing control to be passed back to the kernel. In this way, the operating system can maintain exclusive control over things like access to hardware and memory. The term user mode resource generally refers to one or more CPU registers which contain information that the running program is not allowed to alter. An attempt to alter these resources generally causes a switch to supervisor mode, where the operating system can deal with the illegal operation the program was attempting, for example, by killing the program. Next, we are going to discuss methods of requesting system services. There are two techniques by which a program executing in user mode can request the kernel services: system call and message passing to system programs. Every operating system is designed with one or the other of these two facilities, but not both. First, we are going to discuss system call. System calls provide the interface between a process and the operating system. System calls are typically written in a high level language, C or C++, and mostly accessed by programs via a high level application program interface rather than direct system call use. Assume that a process wishes to invoke a particular target system function. Using system call approach, the user process uses the trap instruction. The idea is that the system call should appear to be an ordinary procedure call to the application program. The operating system provides a library of user functions with names corresponding to each actual system call. Each of these stub functions contain a trap to the operating system function. When the application program calls the stub, it executes the trap instruction, which switches the CPU to kernel mode and then branches indirectly through an operating system table to the entry point of the function which is to be invoked. When the function completes, it switches the processor to user mode and then returns control to the user processes, thus simulating a normal procedure return. As an example of how system calls are used, consider writing a simple program to read data from one file and to copy them to another file. A user program containing the code for doing this will contain some instructions as shown in figure. Corresponding to each user instructions, there will be a series of system call to perform that instruction accurately. Typically, a number is associated with each system call. System call interface maintains a table indexed according to these numbers. The system call interface invokes intended system call in operating system kernel and returns status of the system call and any return values. The caller need know nothing about how the system call is implemented, just needs to obey API and understand what operating system will do as a result call. Most details of operating system interface are hidden from programmer by API. System calls can be roughly grouped into 5 major categories: process control, file management, device management, information maintenance and communications. Next is message passing to system programs. Another method to use system services is to use system programs. System programs provide a more convenient environment for program development and execution. Some of system programs are simply user interfaces to system calls, whereas others are considerably more complex. In this approach, the user process constructs a message that describes the desired service. Then it uses a trusted send function to pass the message to a trusted system process. The send function serves the same purpose as the trap, that is, it carefully checks the message, switches the processor to kernel mode and then delivers the message to a process that implements the target functions. Meanwhile, the user process waits for the result of the service request with a message service operation. When the system process completes the operation, it sends a message back to user process. System programs can be divided into 7 categories. First is file manipulation. These system programs are used to create, delete, copy, rename, print, list and other generally manipulates files and directories. Status information. Systems programs required for asking the date, time, available, disk space, number of users or similar kind of status information. Third is file modification. System programs responsible to create and modify the contents of files stored on disk or tape. Fourth one is programming language support. Compilers, assemblers and interpreters used for programming languages are system programs which are provided to user with the operating system or separately. Next is program loading and execution. To load a program in memory and to execute it, many system programs like absolute loaders, relocatable loaders, linkage editors and overlay loaders are required. Next is communications. The system programs used for creating virtual connections among processes, users and different computer systems. Next we have application programs. Most operating systems are supplied with programs that are used to solve common problems or to perform common operations. Such programs include web browsers, word processors and text formatters, spreadsheets, database systems, compilers and games, etc. Most important system software for an operating system is command interpreter, the main function of which is to get and execute the next user specific command. Finally, we have conclusions. There are many factors to be considered before developing an operating system. These factors differ from application to application. There are many basic functions of operating system. These basic functions are provided by almost each operating system. The processor can work in 2 modes depending upon the situation it is performing user activity or kernel activities. Also, the services provided by any computer system can be used in 2 methods, using system call and using system programs. Thank you.